In this video, I will go over the RC Test suite of tools on the BeagleBone Blue that are useful in testing and debugging. So I'm going to go through these in alphabetical order, or whatever comes up first in the list I have here. And so these are commands that are useful in if you want to test that things work. I can show you these commands if I do RC underscore and then just hit tab, and you can see we have all these options. So I'm not going to go over all of these because that's a lot of commands to go over. I'm just going to go over a few of these which show how some sensors work, or they'll output sensor data. They will control motors, servos, just the simple ones that are not good to know about, and will help you in debugging and fixing any problems that you may have. So the first one we're going to go and run is RC altitude. So if I hit enter, this initializes our barometers and our DMP, which is our onboard IMU. So I have not calibrated my accelerometer, as you can see. There's another command you can run to do that, and well, as is said here with please run RC calibrate accelerometer. If you run that code, it'll basically tell you to take your BeagleBone and place it in certain positions, to rotate it 360 degrees continuously until this calibration script completes, and that calibrates the IMU, onboard IMU. So here you can see it says waiting for sensors to settle. It does that for a little bit, and then you saw that this data popped up, and these are our altitude, velocity, accelerometer bias, our altitude based off of the barometer, and vertical acceleration. So, and it's got units for these. There's a couple commands that will show you kind of the same information, but if you're going to test out your IMU, this is one of those commands. So we're going to move on to RC underscore battery monitor. If I hit enter, a lot of commands need to be run as root because the pins that these programs need to access typically require root access. So I'm going to put sudo at the beginning of that and hit enter, and I'm going to put in my password. So here it outputs our battery voltages. Now we have our jack voltage here, and that's 12.13. I'm powered through a wall wart, 12 volt 2 amp wall wart that goes into my DC power jack, as you can see here. It also says we have a 2S pack that is at 8 volts. That is not true. This here is the LiPo header, or LiPo input plug. It's really common for LiPos to use these plugs, but we're not using that, and so this value is wrong because we don't have a LiPo hooked up. And the BeagleBone Blue only does support 2 cells, so that is why 2 cells is there. I don't think it would ever show anything else other than 2 cells because more than 2 cells are not supported. But that is some information that's printed out. And then it says cell voltage. That'd be voltage for each cell is at 4.16. The reason it's probably returning these high values is because this DC power jack is powered. That is how this BeagleBone Blue is being powered. So it sees a high voltage, and as you can also see this animation here of these green lights going up. That is a charging indicator because the 12 volt barrel plug is also an interface for charging the LiPo. So if you have a LiPo battery hooked up to your BeagleBone Blue, you can use the barrel plug to input 12 volts, and you will be able to charge your BeagleBone Blue without disconnecting that LiPo battery. But as you can see, we don't have that hooked up, so those values aren't correct. but our jack voltage, DC jack voltage, is correct. So I'm gonna stop that with the Control C, and down to my bottom right. I forgot to mention this, but this is just a program. It's called HTOP, and it shows me what processes are running. It just helps me more easily visualize when a process is running, make sure it ran properly, stuff like that. But it can mostly be ignored. So now we're going to do RC check battery. A lot of commands in here seem to be redundant, but they will output slightly different information. So we'll go through them anyways, but we just did RC battery monitor, and now we'll do RC check battery. So you can see the pack voltage, which would be a LiPo battery, is at 8 volts ish. It's bouncing up and down. That would be the same voltage as this. This is probably more of a raw input, and this is an averaged out input. And then cell voltage, so that would be LiPos consist of many cells, as you saw here. That this BeagleBone Blue supports 2 cells. So this would be approximate cell voltage of each cell. And then we have our DC jack, which you can see is pretty consistent because that is actually being powered, but none of these are. So we can close that, and we can move on to RC test, ADC. So the ADC is your analog digital converter. You have a plug for this on your BeagleBone Blue. That is this black one right here, this black header. I may be able to point at it better with I guess these tweezers are here. This header right here, and this is outputting your first ADC 0, ADC 1, 2, and 3 values. Those are not pulled low, so they're just floating values. And then we have our DC jack and our battery. Once again, the battery is false, and the DC jack is true because we have a DC jack hooked up. Okay, now we can move on to RC test BMP. That is your onboard barometer. So here we get a temperature output, a pressure output, altitude, and a filtered output of our altitude. So our temperature is 38 degrees Celsius, pressure, as you can see, these, I'm not going to read these values out to you, but they work. And if you need to test out your barometer, onboard barometer, here this would be the command to do that. So then we have RC test buttons. So this is more where we get to user input. So RC test buttons, enter, and now I'm going to press buttons to see a response. So with this command you want to be careful though, because 2 of the buttons are not user input buttons. They are a power button and they are a reset button. So please don't press those while your BeagleBone is powered. Nothing probably bad will happen, but your BeagleBone Blue will either reboot or shut down. So I'm going to press the user 1 and 2 buttons. Before I do that, I'll tell you they are labeled, but that is your power button and that is your reset button, as they are labeled down here on here as well. And then these 2 are user buttons. So I'm going to press mod, and you can see it's mode, but it is abbreviated or shortened to mod on the silk screen on the BeagleBone Blue. And then we also have pause. So they don't actually do any pausing or mode changing, but if you were to implement this into your program and say your program had different modes that it could be turned into or set to, it may be useful to use those buttons because they are already labeled mode and pause if you need to pause and start your program. So those user input buttons are there. So then we can move on to the IMU. The command for that is rctest, and then we'll do DMP actually. It used to be rctest IMU, but now it is rctest DMP. I'm not quite sure why they changed that, but it is what it is. So we can enter that, and now you can see we have options. There are arguments to this command. Some of the other commands above also had arguments, but they will run without any arguments. They'll just output all the data. Some of them you can tell it, I only want to see the temperature, or I only want to see a certain ADC value. But I had them print them all. So let's add an argument. So rctest DMP, and we can do, say, -G. That is print gyro data. Actually, we'll do compass first. So -C. So here's your raw compass value and your filtered compass value. So the raw compass value comes from when it prints out the value it gets as it takes the sample, and then the filtered is mostly that value becomes averaged, and you get a more consistent value, more meaningful value. So I'm going to actually turn the BeagleBone blue, and we'll see if this value, or how this value changes. So you can see I've turned this BeagleBone blue on 90 degrees, and our compass value is now 50. Let us go. Also, actually, I should mention raw compass and filtered compass are two different values. There is some reading you can do about it. I might have to find that, but there are different so for example, you can onboard compass values can be returned in either radians or degrees, and then there's some other modes in which data can be represented. So these two are actually probably are not related to each other, except for that they're being converted from your raw value into a filtered compass value. It's not an average. I shouldn't have said that. But we can turn this, and you can see the value changes. So our onboard compass works. So this would be a great way to test that our compass is working as it should. So I'm going to put that blue back. Maybe it'll focus on that again. Okay. So we'll move on to the gyro. Oops, sorry. -G. Enter. So you have an X, Y, and Z axis on your gyro. It's a 3-axis. The IMU is a 9-axis accelerometer. It has 3 magnetometer axes, 3 gyro axes, and 3 accelerometer axes. So with the gyro, I can turn this, and you can see it'll see a value, and it's currently now we're measuring a acceleration of change in like a rotational acceleration, as you can see there. We can also do that, and you can see the value is changing also in this axis. If you look closely, you can see on the BeagleBone blue that there is, it's kind of hard to center it in the camera, an X, Y, and Z silkscreen right here, which tells you the direction your BeagleBone blue sees your these changes take place in. So we can use RC calibrated accelerometer. Yeah, we can move on to our temperature. So that is T. Now we're outputting a temperature. The IMU, I believe, may have a temperature sensor, or that might be coming from the barometer. I'm not sure. So there's also these interesting ones, and this goes back to here when I was saying these values come out differently than, or they're interpreted and calculated differently. Let's do -T, and you should see we have, it will always warn me about this. This is something you should do, but it's not necessarily required to do some tests. So if I turn this BugleBone, we are getting a degree value. So right now we're turning the BugleBone blue in this axis, and you can see as I turn it, we get a change in degrees. And this is the more expected output, I guess, of the, say, filtered compass value or the gyro. But we're able to turn the BugleBone blue, and we're also able to turn it in this axis, like that, and we have a change on our accelerometer. When you're calling these in code, which we'll probably do a separate video about, we have a when you call for using the RCPY library, the IMU data to send you data, it will send you all of this data in a very large array, and you have to go through this array and find the data you're looking for. So that's important to know, because you're going to get it will return a very long array with a lot of values. So that was minus t. We won't go through all of these, but all of these do is change different ways that you receive data, interpret the data. And this print I2C bus warnings, these sensors are on an I2C bus, but that's not something I'm going to cover right now. Okay, so I'm going to clean this up with the clean command. And we were just doing DMP, so we'll move on to servos. Now, for this demo, I'm going to hook up some servos to my BugleBone blue, and then I will be back. So we will have to move servos to a different video, because it seems that at the time of recording this video, servos do not work properly, and we have to sort that out. It's a problem with the libraries that BugleBone blue uses to control the servos. Likely something wrong with the frequency that it sends the servos, but otherwise servos will typically work. We'll probably have to do a separate video for servos. Until then, we will move on to our next commands. So I've hooked up a motor here for a later command. But before we do the motors, I'm going to go through a couple other commands. So first we're going to start with RC test drivers. If I type in RC test drivers, we get a lot of information. We get our kernel version up here. We get the Debian image version from the BugleBone blue website. If you download the image of the Debian image, their version convention, I guess, would be the date of the release. And then it tells you what Debian version you're running, which is 9.7. At the time of making this video, this is the latest version. Next, we have all this information. So you can see all of this passed. A lot of the time it'll throw a failed here and there if some library is improperly installed, or you have a misconfigured pin mapping. These are errors I will go over in a different video, but for now you can see, especially for this video, I made sure all these things worked. PWMs, some of them are used for controlling the servos, but those don't seem to be working in this version. So although those passed, servos don't work, and so we'll have to see what happens about that. Hopefully that issue is resolved at some point. You can see LEDs, ADC, UART controls, or UART communications, SPI communications, your PRU, PWM, GPIO, all of that passed, and then also here at the bottom shows you your BugleBone model is your BugleBone blue, and then your robot control library version 1.0.4. This is where the RC test name comes from. This is robot control test. If you go to the GitHub, it's a lot very useful. You can dig through some of the code for this library, but we won't be doing that here. So let's move on to our next command, rc test LEDs. So if I do rc test LEDs, and you look at the BeagleBone Blue, starting from these user LEDs and these LiPos LEDs. So if I hit enter, you'll see it cycle through the user LEDs and the LiPo LEDs. The LiPo LEDs are actually user controllable LEDs, but they are not easy to control through software. I have found personally, but hopefully at some point that'll be made possible. I'm going to run that again so that you can see it, because I know the camera view is not directly on the blue, although I could bring it closer. So if I'm going to hit enter. Yeah, nice LED cycling animation. So move those back to the center. And is it focused? Yeah, okay. So next we'll test our RC test motors. So if I do RC underscore test motors, I'm going to run this command, and it's not going to work because it requires some arguments. But to show you those arguments, I'm going to just do that. So you don't have to specify all these arguments. You can do just one of them. So you don't need to tell it the, for example, the frequency. You can just tell it your duty. RC test motors takes in a value from -1 to 1. There is another video on this function, but I'll do it here as well anyway. -1 would be full backwards, 0 would be no motion at all, and then 1 would be full forwards. So to show you that, I'll do -1, and because I am not going to specify a motor -m and then a number, it will actually send this output signal to all the motor outputs. So we'll hit enter. That shouldn't be, yes, okay, enter. So you'll see my motor is going to spin, and I'm going to, yeah, I'm going to cancel that now, and we'll do 0. So it's sending a duty cycle of 0, and nothing's happening, because that is your stop function, or stop value. And I'll send 1. And you can see the motor is actually spinning in the opposite direction now. We also have -s. So -s allows you to send a changing pulse width modulation signal to the DC motor. So -s means sweep, and if I hit 1 is the highest value it will go to. So if I hit enter, you'll see it slowly go back and forth. Yeah, and then leave frame. Okay, so cancel that. And you can see it prints out in the terminal the back and forth duty cycle. Okay, we're going to clear this up. So that is most of the commands for our RC test library. Our RC test software suite. If you want to see all these commands, you can do RC underscore and then hit tab, and you will see all of these that we didn't go over. There's a lot of other interesting functions, but you probably won't be using these ones as much, but feel free to explore that, I guess. Hopefully this video is useful, and that concludes our RC test software suite video. Thank you for watching.